Welcome to the Lessons from Lab and Life podcast from New England Biolabs. I'm your host, Lydia Morrison, and I hope this episode offers you some new perspective. Today, we're sharing the last episode in our molecular cloning series, and I'm joined by NEB production scientist Lindsay Spiegelman to talk about the seamless DNA assembly method, NEBuilder, which was developed here at NEB. NEBuilder HiFi offers fast, accurate assembly of DNA fragments, including the ability to easily assemble DNA libraries, as well as the ability to perform multisite mutagenesis in a single reaction. So let's jump right in and learn more. Lindsay, thanks so much for joining me today.
Hi, Lydia. Thank you for having me.
Oh, yeah, my pleasure. I was hoping that you could tell our listeners what seamless cloning and DNA assembly are.
Sure. DNA assembly is exactly what it sounds like. It's taking more than one DNA fragments and then putting them together so that you end up with a single DNA fragment for multiple components. Seamless DNA assembly is when you're able to put the fragments that you want together without any unwanted sequences at the junctions of the fragments. In typical restriction enzyme cloning, it necessitates having a restriction site at the termini of your DNA fragments so that they can be put together, but you may or may not want those in your final product. Seamless cloning gets around this and just gives you the exact sequence that you want.
Wow, that sounds like a really powerful technique. What is NEBuilder HiFi DNA assembly, and how does that work?
So NEBuilder is a technique relying on the synchronous activity of 3 different enzymes that work in one reaction. So the first step is to design your fragments to have overlaps at the ends where you want them to be joined. And by overlaps, I mean homologous sequences of DNA. So the first activity is exonuclease that chews back the 5' ends of these fragments, allowing the homologous 3' overlaps to then anneal. A DNA polymerase then fills in any gaps left behind by the exonuclease, and a ligase seals the nick, giving you one fragment in one reaction.
So why would someone want to use NEBuilder HiFi? What would they use it for?
So NEBuilder is really advantageous because of the amount of time and energy that it saves. So in traditional restriction enzyme cloning, there are a lot of steps from the beginning where you have to design primers that include restriction sites, and then you have to do a PCR, a restriction digest, and a ligation, and there are cleanup steps in between. And these reactions are all kind of low efficiency. So NEBuilder combines all of those assembly steps into one reaction at one temperature. So it saves money on reagents and your time doing the work. It's also very intuitive to design the primers that you need to get your fragments because it all operates on the same principle of having overlaps of the same sequence at the termini of each fragment.
And how would someone use the fully designed DNA?
So there are a lot of applications that people want to assemble DNA for. The primary one is probably to get a plasmid with a gene of interest for downstream study. So this could be for protein expression. This could be to generate a plasmid for a library screen. There are endless applications.
So why choose NEBuilder HiFi over other cloning methods, such as traditional cloning? I know you mentioned that there's an incredible time savings compared to traditional cloning, but what about something like Golden Gate assembly or another cloning method?
Even compared to Golden Gate assembly, NEBuilder saves a lot of time, especially in the design phase for anything requiring restriction enzymes, whether it's traditional cloning or Golden Gate cloning. There's a lot of time that you have to put into domesticating the system and placing all the restriction sites. With NEBuilder, every assembly is going to work the same way. You're just going to have overlaps or identical sequences between the ends of the fragments that you want to join together. And again, even compared to Golden Gate, NEBuilder saves a lot of time because you can accomplish the assembly in one reaction at one temperature in only 15 minutes.
You mentioned domestication of the system. What does that mean?
So domestication of a system just means making sure that it's going to work for your application. with restriction enzymes, what this means is making sure that you don't have any unwanted restriction sites that are going to result in products you don't want. So if you have a restriction site in the middle of your plasmid, that's not where you want to put in your fragment of interest, you're going to cleave the vector there, and then your assembly won't work.
Understood. That seems like a very important aspect of the assembly process, but that's not an issue for NEBuilder.
Right. So if you wanted to use that plasmid, you would actually have to mutate it before you could use it for Golden Gate, and there are no issues like that with NEBuilder.
And how does NEBuilder compare to similar technologies like Gibson assembly?
NEBuilder actually outperforms Gibson assembly products. It has several advantages, and we have data to show that it outperforms Gibson with 2 fragments all the way up to 12 fragment assemblies, as well as bridging a double-stranded DNA vector with a single-stranded oligo, and in the context of annealed single-stranded oligos and combining those with a linearized vector. In our hands, we see that it typically generates about 5 times as many successful clones.
Can you expand on what makes NEBuilder so versatile?
Yeah, so NEBuilder, because it's based off of such simple principles, can be expanded and applied to a lot of different applications. So for example, NEBuilder can actually be used for multisite directed mutagenesis. So if you have a single nucleotide that you want to mutate, we have a kit specifically for that, and it can be done with PCR, but that becomes a multi-step, multi-day process if you need to put in several mutations because you can only do one at a time. With NEBuilder, you can put in multiple mutations by simply designing complementary primers at each mutation site. So let's say, for example, that you want a mutation at base 500 in a 1000 base pair fragment. What you would do is then split that fragment into 2 pieces with that mutation at the overlap junction. So you would have primers that start at the beginning of the fragment, and then you would have your first reverse primer at the point of the mutation. You would then have a complementary 5' primer that would be the beginning of the second fragment. And so what that gives you is 2 500 base pair pieces with the mutation at the overlap region. So then when you assemble them, the mutation is present at that site. And you can do that as many times as you need with smaller fragments to have multiple mutations in one reaction.
Wow, certainly a very helpful application. Are there a certain number of fragments that NEBuilder HiFi is appropriate to assemble?
So we recommend using NEBuilder for assembling 6 or fewer fragments in one reaction. That being said, we have had people that come to us and want to use NEBuilder to assemble more fragments, and that can be accomplished by doing a sequential assembly. So NEBuilder can actually be used for linear assemblies. You don't have to put everything into a plasmid all at once. So if you need to assemble more fragments, what you can do is take a subset of your fragments, assemble them. You can then use your assembly reaction as a template for PCR, amplify that entire fragment, and then proceed to a second assembly with the rest of your fragments. So about 6 fragments at a time, but the technology can be adapted to incorporate more fragments.
Interesting. I see. So you can kind of stack different individual fragment assembly reactions. That makes a lot of sense. I know it can also be used with 3' and 5' mismatch assembly. Can you explain a little bit more about that?
Yes. So what this means is that, this is the simplest example. Let's say that you have a plasmid that you've linearized, so you've cut it open and you want to put your gene of interest into that plasmid. But there's a restriction site at the ends of the plasmid that you would prefer not to have in your final product. So this gets back to that seamless cloning idea. So NEBuilder can actually remove unwanted residues as long as it's 10 or fewer at these ends. So the 5' exonuclease will go ahead and remove the unwanted nucleotides at the 5' ends, but the polymerase in NEBuilder is actually capable of removing a few bases from the 3' ends. So when you have your insert, as long as you've designed it to have overlaps to the vector and ignore the sequence you don't want, it will anneal to the target sequence on the vector, and then you'll have the 3' cut site that you'd like removed kind of hanging off of it. And then the polymerase will actually remove that for you before it fills in the gaps.
Wow, that's a nice, interesting functionality of the polymerase that's used in the reaction. What can make the assembly process even easier for someone who's using NEBuilder HiFi or someone who's new to it?
We have a lot of recommendations to make NEBuilder as easy as possible, starting with primer design. So we have an NEBuilder tool on our website that will actually design your primers for you. So all you have to do is go to the website, put in the sequence of your plasmid and of your fragments that you want to assemble, and the tool will output your primers for you. So we definitely recommend that because getting your primers designed is a very important part of the process. Other things that you can do to make sure that your assembly works are use clean preps of DNA. So we have found that gel purifications can cause problems in the assembly because they bring along a lot of salts. So whenever possible, we recommend that people use column cleanups instead of gel purification. And finally, the competent cell choice is incredibly important to the success of NEBuilder. NEBuilder requires a competency of at least 1 × 10⁸, and a lot of homemade cells are not that efficient. So if you use good competent cells, you're really giving yourself the best chance of getting your desired product.
Wow, that seems like a lot of helpful information and tools for people starting their journey with NEBuilder. Are there any other resources that we could offer if anybody needs any additional support?
Yes, we have a ton of resources on our website. We have a long list of application notes that will walk you through how to use NEBuilder to achieve some of the applications we discussed earlier, such as multisite mutagenesis. We have a brand new protocol calculator that will tell you exactly how to set up your reaction. All you have to do is put in the lengths of your fragments and the concentrations of your DNA. And we also have a technical support team that's available to help you with anything that you might need, from designing your primers to troubleshooting your reaction if it's not working.
Amazing. What are your top 3 tips for someone who is new to using NEBuilder HiFi?
So one of them I've already alluded to would be using our tool to design your primers. Getting the overlaps right is the first step towards getting your assembly to work. We also recommend that you make sure that your preps of DNA are as clean as possible. We often hear from customers that have trouble with their assemblies when they've performed gel purifications to clean up their DNA fragments. Unfortunately, gel purifications can result in bringing along a lot of salt into the assembly that will inhibit the reaction. So we recommend using a column cleanup whenever possible. And finally, good competent cells are essential for NEBuilder. NEBuilder requires a competency of at least 10⁸. So homemade cells are usually not competent enough to give you your product. So if you do those things, you've already solved a lot of the problems that most of our customers face in getting their assemblies to work.
That's wonderful. Thank you so much for sharing those super helpful tips with our listeners. And thanks so much for explaining the NEBuilder HiFi DNA assembly system to us and how it can help our customers achieve their seamless cloning goals.
Oh, you're very welcome. Thank you so much for having me.
Thanks for joining us for this episode of the Lessons from Lab and Life podcast. Please listen again soon. And until then, keep learning, keep inspiring, and keep sciencing.